Hello and welcome to day three. Day three for me, not for you. It is the 10th of December, so I'm playing a little bit of catch up here. So let's jump right in. Day three of Advent of Code. I'm going to be going through the problem here called Toboggan Trajectory. I'll include a link to the actual problem below the video. So if you wanna go and read the full thing, go ahead, check that out. But basically what we've got here is we have a set of empty spaces represented by periods, and then a set of trees that are represented by the pound signs or hashtags. And what we are given is a slope, so right 3, down 1, and we are going to go right 3 and then down 1, and we're going to look at whether or not there's a tree there, and we're going to count the number of trees that we run into on that particular slope. So in this case, we end up with 7 trees. Now the tricky thing here as well is that this particular pattern repeats out to infinity, right? So we're going to be given an input that is a certain number of characters long, and we need to count all of that out into infinity. Or we can simply use a modulo operator, which is what I'm planning on doing. And that will reset us to the beginning of the pattern, and we don't have to worry about memory that way. Okay, so the locations we want to check are whether there's a pound sign, hashtag, right there, and we want to count the trees. So what we're going to do is we're going to copy this particular pattern, and we're going to use that as the example. We're going to use this one. Actually, this is the full pattern right there. So let's use that one as the sample for our input here. Okay, and we're going to come over here and we're going to do that right there. Okay, perfect. So this is a very simple pattern, and we're going to count all the way down until we hit the final row, and then we're done. Right? Once we hit the final row of data, then we're done, and we just need to count how many trees we run into on before we hit the final row. Okay. So we've got the basic code set up for day 3. I read the input from our input.txt file. Let's split on the new lines so that we have each of the new lines, and so we're going to iterate through line by line. So in this case, we've got our slope. I'm just going to call it slope equals, and they said 3 down, 3 right 3 down 1 here. So we're going to call this rise over run. So this will be 1, 3, and we're going to say positive is going down the row. So 1, 3, and we are going to iterate through the rows of data using this particular slope. So we're going to say for x in range length data, and this will allow us to get every single row of data. We will probably have to add in an iterator here for the particular slope, right? Because we're going down one row at a time. So this will be slope 0. So we're going to increase that by 1 row each time. Yep. So we've got our slope down, and then we need to check every third after that. So let's double check here that that we haven't run out of rows at this point. So for x, so if x times our slope, the first value, right? If our first one. If x times our slope is actually just if x is less than or equal to the length of the data, then we can continue. So let's actually change this slightly. If x greater than the length of our data, we're going to break. Or maybe we'll just, we'll break. I actually wonder if we don't actually need this piece. I was checking to see, but we're already iterating up to the length of the data itself, so we don't actually need that piece. Instead, we'll just add a check that says if the data at x times the slope down, right? So we're going through the iteration down. So this will actually just be x. And this will now be the column. We're moving across. So this will be the x times slope 1. So we're going 3 over now. But we have to take this particular piece, and we have to use the modulo operator, which will be the length of data, the very first row of data. We'll just use the first row. And we need to check if that itself is equal to the pound sign, and if so, we need a trees operator, or variable. Trees is 0, trees plus equals 1, and then we can return trees, just like that. Theoretically, this will return 7, given our current input. Let's run this and find out. Function, what is it printing out? Return trees. Trees is 0 plus equals 0. Huh. Data. So we're doing part 2 data. I had my file set up wrong at the beginning. There we go. Okay, so that does in fact return 7, which is exactly what we want. So let's get the full input and let's see if we get any errors. Oh, goodness, how long is that? 200 lines or so? 324 lines? Okay. Okay, and then we'll test this out and see if we get a correct value. 207. So we must hit 207 trees. If 207 is the correct answer, yes, it is the correct answer. Okay, so now we'll continue to part 2. So with a slope of right 3 and down 1, we are hitting 207 trees. Okay, part 2. So we are now given multiple slopes. Right 1, down 1, right 3, down 1, which is the one we've already checked, etc. So in the example above, the slopes would find 2, 7, 3, 4, and 2 trees, respectively. So we need to double check that we're getting those correct slopes when we change those correct number of trees when we change to these slopes, and we multiply them together to get 336, which is the answer that we're looking for. So, okay, so let's throw that in here. Yeah, we'll keep this over here on the right-hand side. So now we've got a set of slopes is going to be, you know what, I am going to keep it consistent with what they have here. So we're going to say 1, 1, we're going to say 3, 1, we're going to do 5, 1, 7, 1, and then 1, 2. Okay. And let's just create a function. We'll call this get trees, and we're going to have the data, we're going to have a right, and we're going to have a down, just to be consistent with this. Let's see here. So we've got trees is going to be 0. We're going to say for x in range length data, kind of similar to what we did before. but in this case, now we have a down 2. So if x, let's say if x times down is less than or equal to the length, is greater than the length of data, then we are going to break the for loop. Else, if we have data, we're going to say x times down, right? So that's the number of rows down that we've gone. And we have our columns now, which is x times right, but we also need to use that modulo. There we go. Length data 0. Okay, so theoretically, if we actually take this one and we run this through, let's test this out real quick. So return get trees data, and this is going to be right 3 down 1. So theoretically, if we do that, we should actually get the same answer. Okay, so there we go. So 7, none. Perfect. So turn trees. Okay, so now we need to say total. Oh, wait, actually, we need to get the product. So let's say, we'll say total trees is going to be an array, and we're going to say for x in for slope in slopes. Total trees dot append the get trees function for data and slope 0, slope 1. Okay, and let's print out the total trees, and we'll return. We got to import from math, import prod, and we return prod of total trees. Okay, let's try this. 336, 2, 7, 3, 4, 2. Okay, so over here, 2, 7, 3, 4, 2. Perfect. That is how we're going to do that. Excellent. Okay, let's pull this back over here. Let's remove that. Let's actually clean this up just a little bit. So we're going to say return prod, which is total trees. Total trees can actually be rewritten as get trees data slope 0, slope 1 for slope 1 for slope in slopes, that way, which means that this whole piece can actually just go in there. And we can comment that out. Let's just double check. Yep, 336, perfect. So we can actually use just list comprehension and make it slightly more compact. Oh, that also means that we can get rid of all of that as well. Okay, so 7 and 336, we're still getting those. Let's take a look here. Let's get the puzzle input again. There's our puzzle input. Okay, and so that's 207, which was our original answer, so we know that nothing there has changed, and let's test and see if this one worked. Bam! There we go. Correct answer, just like that. That was, not too shabby. Okay, so let's go back to our code, and let's clean up the code just a little bit, because there's probably a way to condense this, right? We've got get trees, which is essentially the answer, right? Given the right and the down, that's essentially what we need. So what we can actually do is we can just say get trees data, and we can say 3, 1 there, right? We actually don't need part 1, that part 1 function. That's going to give us the same response. Good, okay. And then here we can say prod of get trees data slope. Actually, we can actually just do this, right? Just like that for slope in slopes, and then slopes is this. Well, that's not very pretty, but it works. Okay, and now we've actually gotten rid of our part 1 and part 2 functions, and now all we have is actually the getTrees function, which captures the functionality that we need for both parts. So it's just much more condensed code. Not very pretty though. Let's just say slopes equals that. That's better to read. So we get the trees for the slope on the data for the slope 0, slope 1 for slope and slopes. And yes, it does look like everything is working there. Okay, so we will leave it there. Got this pretty condensed down. So thank you very much. Hope you enjoyed it. Hope it was at least helpful in some way to do the problem solving that way. If you do have any questions though, let me know. Throw comments, questions below the video. Let me know what you think. If you want to see more videos like this, make sure you like, subscribe to the channel, and we will see you in the next video.